Okay, welcome and Blake and Rigney and Sheva and Isabella and Andres and Casey and Anthony and Vanessa and Lorna and Tony Diego and Bruno and Dean and River and Tazil and Cameron and Sarah and Juan and Quinn and Lexi and Adam. Okay, much better than it was at UCLA. It could take hours to go through all the names. I think I got them all. So as I mentioned, today's an important day because we are going to review for the exam and talk about that. But that's at the end, so you have to stick around until the end. What I want to do is start off on looking at the quiz. So let me share my desktop. You had the students in your last class at UCLA. Yeah, sounds about right. Okay. Yeah, we had to check IDs on the face-to-face classes. And that will happen, by the way, when you guys transfer, if you transferred anywhere like UCLA or Berkeley or Davis or any of the big universities. It's just the way it is. So it's very different at LTCC when we have small classes. It's kind of nice to have small classes. I can actually get to know people. Even on Zoom, I can kind of figure most people out. So let me share my desktop. And let's take a look at the quiz. So consider the graph of the function y equals f of x below. A is determine the values of x where f is not differentiable. So what I like to do, just for organization purposes, is I like to read left to right and just see what happens. So I'm going to go to the graph. And just for fun, how about at x equals -3? Is that differentiable?
Yes.
Yeah, that one's differentiable. There's no problems. All right. I'm going to keep going, and I'm going to move on. I'm going to move on along the curve. And what happens at -1? Is it differentiable at x equals -1? What do y'all think?
No.
Yeah, it's not, because if you look to the left of -1, you're going up. And if you look to the right, you're suddenly going down. It's not some nice, smooth thing. I like to think about is putting my finger on that spot, and if it's going to cut me, it's not differentiable. If it's smooth, it's differentiable. So -1 is our first one. So x equals -1 is not differentiable. Okay, then we're going to move on. And again, kind of having a good time sliding down the slide. We're not getting punctured or anything. And then what happens at 0?
It jumps.
It jumps. It's not continuous. And we saw, if you watch the video, that if you have a discontinuous function at a point, it's also not differentiable. That was a theorem. So x equals 0 is also a non-differentiable point. Any questions on that? Okay, then we can move along. And then what's happened at x equals 1? What do we have?
Infinity.
Yeah, an asymptote in particular. So when you have an asymptote, you don't get differentiability. So 1 is also not differentiable at x equals 1. All right. So then we go over, and by the way, if it's not continuous, it's not differentiable. That was a theorem we had. So then we move along and slide. How about at x equals 2? There's something interesting going on there. Is it differentiable?
No, because it's a removable discontinuity.
Yeah, if it's not continuous, it's not differentiable. That was a big theorem. And having a hole makes it not differentiable. But does a limit exist, by the way, at x equals 2? What do you think?
No.
Yes.
Okay, I'm hearing both. The limit exists. Remember, the value doesn't matter. What matters is going left from the left and going from the right and seeing if you're going to be able to say hi to each other when you meet. And yes, you can say hi. Okay, you can't get to the point 2, but you can like yell at each other and say hi, and you'll be able to hear each other because you're close enough. So 2 is not, there's no limit. There is a limit. It's not continuous, but if it's not continuous, it's not differentiable at 2. So 2. Then let's move along. Past 2, any problems? That's nice and smooth. You're going down a slide, no problem. So that's it. So for part A, the points where it's not differentiable are -1, 1, -1, 0, 1, and 2. Okay, let's look at part B now. B is find f prime at -2. So here's -2, and we want to find the derivative. Now, geometrically, what is the derivative? What is the derivative in terms of geometric words? That's the slope of the what? It's the slope of something, of a tangent line. And I tried to make this really easy. Okay, it may not have been, if you don't understand it, it's not easy. But if you understand it, this is easy because this is a line right here. Okay, and I don't know if you recognize this. I made this with Desmos, and I did a piecewise function, and I just let this be x plus 2, I believe, for x less than -1. It's a line, and what is the slope of the line at -2?
1.
Yeah, 1. Rise or run.
Oh my
You run 1,
God.
you rise 1. Is that clear?
Yes.
So the slope of the line is just 1. So that tells us that f prime of -2 equals 1. Any questions on that? Any questions?
Actually, Larry, I mean, I'm wondering, do we have to prove to show the slope, like show the limit from each end, or could we just use the visual and see obviously that the slope was 1?
Yeah, this one's visual. Why can't you use a limit definition?
I guess because you don't have the equation, so I guess
Right.
either way it's still visual.
Exactly. You can't do this. You can't do this with the limit definition because there's no algebraic equation here. If there's no algebraic equation, it's just not possible. So all you could do is eyeball it. But again, I tried to make it obvious. Do you agree this is pretty obvious as a slope of 1?
Oh, yeah,
Yes.
I know, I agree. I mean, for the most part, but I feel like, I was just worried because everything has to be proven, it seems like.
No, not visual. Visuals are never proven. Yeah, so that's a good question. Visuals are definitely not proven. Visuals are just, you got to understand it. That's important. And it's just kind of what it feels like. Any questions on question 1? Okay, on the other hand, question 2 has very different instructions. This is not take a look at the picture and think. This is use the limit definition. Now it's full proof. So use the limit definition of the derivative to find f double prime of x if f of x equals 4 minus 3x. Okay, so now what we need to do is we need to first remember what's the definition of the f double prime?
Taking the derivative of the first derivative.
We have to take the derivative of the first derivative, which means we can't find the second derivative until we found the first derivative. So to find the first derivative, we need to use the limit definition. So I'm going to do that, and I'm going to make it pretty. So I'm going to go into the equation editor. You don't have to, but I'm your instructor, so I probably should. Okay, so I want to go, and here's my f of x. So what I really want to do is I want to take the limit as h approaches 0. And now we're supposed to do f of x plus h minus f of x all over h. So f of x is 4 minus 3x. So first thing, I'm going to make a fraction out of this. I wonder if I could do it this way. Let's see. Nope, but it was 4 minus 3x. Good thing I remembered. So we're going to have 4 minus 3x plus h, and then minus 4 minus 3x all over h. Any questions so far? Equals. So now we just simplify. I tried to give you one that wasn't totally brutal or anything. So now we just simplify, and we have a 4 minus 3x plus h becomes 4 minus 3x minus 3h. And then minus 4, and then plus 3x. Any questions so far? Equals. Well, now what we can do is simplify. So that's the limit as h goes to 0. And then 4's cancel. We have a 4 and a minus 4. We have a negative 3x and we have a plus 3x. So they cancel. What is negative 3h over h?
Negative.
Nice and easy.
Negative 3.
Yeah, negative 3. Okay, I just found the first derivative. The first derivative is negative 3. Now we need to find, oh, do you know what I didn't do? Let's do that. This is f double prime, sorry, f prime of x. So now we need to find f double prime of x. And f double prime of x is f prime of x all prime. Any questions on that? And that again, that's going to be a limit as h approaches 0. And now let's make a fraction. Okay, f of x is 3.
Negative.
If f of x is 3,
Negative.
what is f of x plus h? Oh, f of x is negative 3, sorry. If f of x is negative 3, what is f of x plus h? Negative 3. Still negative 3. If you have a constant function, it doesn't matter what you plug in, you get the number. So yes, wouldn't it end up being 0? It will end up being 0, but that's not a proof to just say it's going to. You can't just say, oh, then we're not going to have any x's left. We need to actually do the work. So using the limit definition needs to have the limit there. You can't use properties or anything like that. You have to have the definition. So we have that's f of x plus h is negative 3. What's f of x?
Negative 3.
Also negative 3. Okay, and constants are the easiest functions in the world. Whatever gets put in, the number that it's the constant of gets taken out, gets pushed out, and the number is negative 3 all over h. Okay, what's negative 3 minus negative 3?
0.
Yep. So this is the limit as h goes to 0 of 0 over h. Remember, h is not 0. H is close to 0, but it's not 0. What's 0 divided by anything that is not 0?
0.
0. So that's equal to the limit as h goes to 0 of 0. And that's 0. And there's our second derivative. Okay, I want to let you know, and this is very important for Friday. If I tell you to use the limit definition, and I don't see LIM on every single step, then I take off points. Got it? Okay, you can't leave that out. LIM is the calculus, and given the fact that this is a calculus class, it's the one piece that is an absolute requirement in every exam. So if you don't get lazy on LIM, okay? Algebra steps, that one you can do a couple steps at once if you want, because that's algebra and this isn't an algebra class, but it is a calculus class, and LIM is the calculus. Okay, so I want to highlight something. The instructions say use the limit definition. So very important on Friday's exam, read the instructions. Okay, if you don't read the instructions, then things can go bad. Takes you longer to type than to write it. Sorry.
Yeah, Larry, I mean, I don't know if I'm out of place in asking this, but I really feel like this is just not possible. I mean, I guess it is possible if everyone else is, doing it, but this is just isn't enough time for me. Like I was in the middle of my scratch work and the time ended and I couldn't type it out. Like I did the work, but I didn't have enough time to put it into the box. Like I just feel like there's no way we're going to be able to do an exam in the amount of time when these are even going to be much harder problems. And
all right, so first thing, so first thing is, if I show you doing it using this equation editor, that doesn't mean you have to do it that way. You can do it. Let me just show you another way of doing it. You just write LIM. Got it? H goes to 0. That's fast. Do you agree? So if you're not very fast at the equation editor, just type it.
It's fast as my fingers can go after I've already written it out. I'm not doing the work on the
Maybe you should practice doing the work on the computer. It's just something we have to do. I'm sorry, it's not my choice. You understand that, right? With Proctorio,
as much as a choice as I have of continuing this class, you're right. It's a choice.
Yeah, you're just right. Do your best. Do your best to type it out. Okay, and practice is the way you make it work. But if you don't practice it, then you're not going to get fast at it. So the key is to practice a lot. Okay. And question?
I have a question, Mr. Green.
Sure.
Kind of on that same topic as well. I always show my work, but sometimes it's like, yeah, I just forget to do like all the annotations. So would you just say that today is like the last time you're pretty lenient towards that because come the exam, it needs to be this way?
Well, if you didn't do it on the quiz, like on the last quiz, I took off points and I put a comment. You all notice I put comments on your quiz? I hope so, because I spent a lot of hours on that. I don't know if you realize how long that takes. So read the comments. If I say, here's something you need to do, then that means you need to do it. Okay. If I don't put a comment on, then you're fine. Does that make sense? So, and this is something I mentioned, 5 minutes ago, but I want to double mention it. LIM. Oops. This LIM, there we go. LIM, that has to be there. Got it? Okay, it doesn't have to be pretty. I do not care about pretty. I do it pretty because I'm your instructor and I think it's easier for you to see me do it pretty than if it was all messy when I did it. So I try and do it pretty, but you don't have to do it pretty. I can read not pretty, but you have to do calculus. That's all I ask for. Does that make sense?
If I may like specifically mention, like for my quiz, I did do the limit as h approaches 0, but like one time, and then the rest was kind of algebraic. So I'm just making that a note. Maybe other people feel the same way.
Yeah, so LIM is what I want to see. And copy and paste makes it much faster. And I don't know if you noticed, I copied and pasted every one of those. Copy and paste doesn't take more than a second. Got it? Yeah, copy
I
paste.
totally lost some points on the last quiz for not putting LIM in each phrase, and I noticed because of the comment.
Yeah, I will take off points. LIM is the calculus, and that needs to be there. Does that make sense? Okay. The algebra, if you skip a step or two in algebra, I'm okay with that because, again, this isn't an algebra class, but it's a calculus class. So you can't skip the calculus, but you can skip a little algebra, and that's okay. Does that help a little bit? Okay. Any other questions? Okay, and I'm sorry about the fact that we're online. This is not my choice. I hope you all understand that. I teach statistics online, but that's much easier to deal with because there's very little notation. Calculus doesn't work so well, but I don't have a choice. I wish, and I actually talked to my dean and she said no. If we could go in, and I even said I'll spend the entire day and we'll do it in like little rotations for the test. She said we can't do that because I thought that'd be better. And you can come to campus, I'll be there, but she won't let that happen. So sorry. I'm doing what I can. Okay, any other questions before we move on? Okay, the next thing we're gonna do is we're gonna do something we haven't done before in this class yet. Okay, and that is, I'm gonna have you guys work in groups, but let me talk about what we're gonna do. So let's go to that guy. All right, so what we've got is we want to look at the derivatives of powers of x. And we played around with derivatives, but I want to organize our thinking. So what I'm going to do is I'm going to look at a table that I've created of some of the most basic powers of x. And those powers of x are x to the -1, x to the 0, x to the 0.5, x to the 1, x squared, x cubed. And what I want you to do is I'm going to have you get into groups.
Hey, Larry, you keep going in and out.
Oh, I'm sorry. Thanks for letting me know. So I'll try to not move my head. That's the key. One of these days, I'll figure out how to get a microphone. The microphone won't connect to my computer. So I'll figure out how to make it work someday. I'll try again, maybe this weekend. So for now, we have to do it with the computer's microphone. So what I'm gonna do is have you go into groups. And what I want you to do, and maybe because you're gonna lose this, maybe you can write down this table on a piece of paper because you're gonna lose this in a minute when you go into your groups. Because when you go into your group rooms, I believe all you get to see is each other, and that's it. So take a look, write down the table. And I could do all of these, but it would take too long. So what I'm going to have you do is do the one you're assigned to. And I will let you know, I'm going to do the assignment. So I'm going to stop the share now so that I can assign you into groups. And I'm also going to pause the recording. And I'm going to have you go into groups, and I'm going to have you do the derivative that you're supposed to do. Okay, we'll see if it actually works. So now we're recording.
Seems to be a pattern emerging.
And let's go ahead. At this time I did it on purpose. The other time something happened, I didn't do anything. This time I did it on purpose. So hopefully this works. So now I'm going to share the screen. And I want to go over this. If n is -1, we get -1x to the -2. If n is 0, we get 0x to the -1. If n is 0.5, we get 0.5x to the -0.5. If n is 1, you get 1x to the 0. If n is 2, you get 2x to the 1. If n is 3, we get 3x to the 2. All right. Now, what we want to do is we want to finish this off for everything. So now let's take a look to see if we can see the pattern. what's happening to the power? So if you look at all these numbers in front of the x, what do you notice?
The same as the power.
Good. So if we start out with n, what should we have? It's an easy. Huh?
Yeah.
Yeah, if you start out with n, we should have n. So we're going to have an n times x. And what's happening to the power of x? Right? What's happening? Yeah, it's going down by 1. So the n becomes an n minus 1. Okay, by the way, is this a proof?
No.
Definitely not. Doing 6 examples and saying everything must work that way, that's no proof. Got it? But here's the way math works, though. It's not a proof, but what it does is it gives you an idea of something that you want to maybe try to prove. So at least we can see if we're going to get this. And that's the big theorem. And this is one, by the way, I will let you know that if you do not memorize this formula on the very bottom, that the derivative of x to the n is nx to the n minus 1, you will fail this class. You have no chance. Got it? But I will also let you know something. That's never been a problem in my 30 years of teaching. It's never an issue remembering this formula. And the reason is you're going to be using it so many times, you're not going to forget it. Okay? It's kind of like your own name. Do y'all remember your own name? Yeah.
Mostly.
Because you've used your name and you've heard your name so many times, you're never going to forget it. Okay? On the other hand, like for me, I got like over 100 students. I'm not going to remember everyone's names. I remember my name though. Sound right? Okay. So I apologize, by the way, if I forget your names. You know, if you see me in 5 years and I remember your name after seeing you, hopefully you understand, because I've had thousands of students. But that doesn't mean I don't want to still talk to you. So same thing is you're going to be using this formula so many times that you will never forget it. But that's how important this is. Okay, literally you'll use it probably over 10 times on every assignment for the rest of this entire course. That's how important this is. Okay. But it's not a proof. So again, I gave you guys these guys. Who do you think has to do the general case, n equals n? That's my job. Okay, again, that's definitely my job. So what I need to do is I need to prove this, and I'm going to let you know is I'm going to prove it for positive integers. Okay, and I'll explain afterwards why only positive integers. It's true for all integers and all numbers actually, but we're only going to do it for positive integers. So the theorem, and this is a biggie, it's called the power rule. The theorem is as follows, and that is very easy to state. D over dx. Whoa. Let's try one more time. D over dx of x to the n is equal to n times x to the n minus 1. And what I need to do to fix this is make this like 48 font, because that's how important this theorem is. It is the most important theorem of the entire class, because you're going to be using it over 10 times every single assignment. That's how important this sucker is.
Is this a new section or is this just adding on to 3.2?
This is 3.3.
3.3, okay, cool.
Yeah, and I guess I should mention, I'm not doing all of 3.3 today. So the reason why I'm not doing all 3.3 is you have a test coming up. So I'm not pressuring you to do an entire section. So I'm doing a piece of 3.3, and then what'll happen is Friday, of course, I do nothing other than grade your test when you're done. You take the test, and then Monday, we'll go over the test, and then I'll finish 3.3. And 3.3 is a major section in this book. It is by far the most important section of all the sections in the entire book. Just let you know that. So it's got some 3 major theorems. This is the biggest, and the other 2 are really big too. Okay, so
That's
there's
just-
your theorem. So I got to prove it.
I have one more question. This is Bella speaking.
Sure.
So for 3.2, some of this looks familiar. I feel like we were using some kind of form of this method on 3.2. Am I incorrect possibly?
Let me go, and I don't know if you can tell all of a sudden you lost the page, but there's a reason. Oh, shit. It's such a pain on Zoom. I have to move things to be able to click on stuff. There we go. That X was behind the pictures for me. Okay, so if I go to 3, and 3.3 is differentiation rules. Okay, 3.2, we didn't have the rules yet. Everything used a limit definition. Okay, unless it was just by looking at a picture. So it was pictures. Again, I'm looking at 3.2. This is the book. And then everything else, you'll see all these limits. All of this uses a limit definition. Do you see that? So 3.3 is the best, not just most important, but it is the best section of the whole book, because the limit definition is a torturous experience. And what 3.3 allows you to do is not be tortured when you take a derivative. And yeah.
What I'm putting together is that this whole d over d of x is equivalent, if not, right, like to the derivative definition.
Yeah, d over x is a derivative. That's just a, so remember I told you that there's 2 ways of writing derivative. One is prime, the other is d over dx.
Yes, I do remember.
That doesn't matter. That's exactly the same thing. It's just 2 ways of writing the same thing.
Okay, that's all. It seemed familiar, and I just wanted to make that connection. Thank you very much.
Yeah. So the problem is, what does d over dx mean? And that's the same thing as prime. D over dx is a nicer way of writing it in front of x to the n, because prime, the problem is n is a power, and prime looks like a power, and then it gets all messy. So I like d over dx for this particular way of writing it. But it means the same thing. Does that make sense? Yeah. So that's just, trying to get the prettiest way of writing derivative. And for this example, it's d over dx. Okay, so here's the proof. All right, now to prove it, it turns out I'm going to need some algebra that my guess is all of you forgot it. Maybe I'm wrong, but we'll see. Okay, not calculus needs algebra, but let's start with the calculus. And I hope you all know how to start the calculus if I want to take a derivative. What 3 letters must go at the very beginning? What 3 letters? Yeah, L-I-M. Let is for limits, but we're not actually proving a limit. We're not using epsilon delta for a limit. We're just going to use the limit definition of the derivative, this is L-I-M, as h approaches 0. There it is. Up. And now we're going to have a fraction. And the fraction is x plus h to the n minus x to the n all over h. Make that bigger so you can see it. Any questions on that? All right, now remember I told you, my guess is that all of you forgot the algebra. See if I'm right. Maybe I'm wrong, we'll see. How do you expand out x plus h to the n? Any remember? Not very helpful, but you never know.
It would be x to the n plus n xh plus h to the n.
No, there's actually going to be an n different term. So it was, if n was 100, just let you know there's 101 terms. Okay, it's harder than you're making it. Let's put it this way. So here's what it is. Okay, what it is it starts with x to the n, and then it's plus n x to the n minus 1, and then plus, and then it's going to be, see if you remember what this is, cn2 x squared. Does that ring a bell at all?
Not at all.
Never learned that. Okay, those are a number of combinations, number of ways of selecting 2 items out of n items. Okay, I told you, my guess is no one remembered it. You're supposed to have learned it in pre-calc, but that doesn't mean you did. It's supposed to happen. So anyway, and then plus, and then it's going to be a cn3 x cubed, cn4 x to the 4th. And what I'm going to do is I'm going to realize that we're going to have an x squared, and then going to x, you're going to have, sorry, an x squared, sorry, this is x to the, not 2. This is n minus 2. And then there'll be an x to the n minus 3 and an x to the n minus 4, et cetera, et cetera. Times h squared. And this is times h also. Sorry, I lost an h here because we're adding h. But here's the thing. The next is going to have an h cubed. The one after that's going to have an h to the 4th, et cetera, et cetera. So now I'm going to use computer programming language. And I remember there were a few. Who's computer programmers in the group? Or computer programmer wannabes? That's okay too. I know there were a couple of you said that's what you want to do. So you need to especially listen because this is important for you. And that is, we call that O of h squared. And that means is that it's going to be an h squared times stuff. Okay, and that stuff isn't going to have any 1 over h's in it. Okay, so if you're going to be a computer programmer, this is really important, by the way. So you need to like perk your ears up. Is that this is how you do computer programming, is you think about it as O of. And that means it's the order of h squared. So it's got h squared times junk. Okay, now I can take this. And what do you see? I can simplify right away.
X to the nth power can be subtracted from x to the nth power.
Exactly. I can cancel out an x to the n. Why must the n's and h look similar? They look different to me. There's an n. There's an h. They look different. So sorry if they look the same. Oh, and your handwriting. That I can't help you with. Sorry about that. That's one reason I type, by the way. My handwriting's horrible. So anyway, we could do that. Well, here's the thing. Now we can factor an h out. We're almost done. So I can pull an h out of here. And that means I'm dividing this guy, and that h is gone, and I'm dividing h squared by h, and I'm left with just h. Now what can I do?
Plug in
Not yet.
the H's.
I can cancel the h's because I have an h on the top as a factor, and I have an h on the bottom as a factor, and the h's cancel. Now I can plug in, and the idea here is that O of h means h times stuff. Well, if h is 0, what's 0 times stuff?
0.
0. So we get n x to the n minus 1 plus 0 over 1. And that's just n x to the n minus 1. And that's the proof. Any questions on that? Okay, I want to mention something. Let me go back to the big theorem again. And that is, this is true for any n. Now, when you're thinking of n, you probably think of 1, 2, 3, 4, 5. But this is true for a half also. Okay, is it true for any number n? Any real number? What do you think? Can I scroll back down? Sure, that's just a proof. You're not responsible for memorizing the proof, but you're responsible for having seen it or not, or I'm not doing my job because this is one of the most important proofs of all calculus. Okay, so you're saying n can be any number, but here's the problem. Do you even know what it means to say x to a power? You all know what that means? Okay, sounds good. All right, if you know what it means, let me ask you something. What's x to the pi? Okay, if you think it's x to itself that many times, well, how do you multiply x by itself pi times? Doesn't even make any sense. And by the way, x can be negative. No, I mean, it can be negative. The definition of the negative, you put it downstairs. If x is to the pi, you've never seen this before. You may have seen it, but you've never been told what it means. And what I'm going to tell you is that's going to be in a couple weeks. So it feels like you know what that is, and then think about it a while, and you don't know what it is. Sound right? But the good news is the power rule, that big theorem I just wrote down, works even for x to the pi. So what is the derivative, given the fact that you don't even know what x to the pi means, like 2 to the pi, what would that mean? 2 times 2 times 2 times a little more than 2? I mean, a little more? That doesn't make any sense. But just trust me that it actually does have meaning. What's the derivative of x to the pi? Yeah, pi times x to the pi minus 1. So the idea is it's easy. Do you agree? And that's it. All right, well, the good news is not only can I do that, but I could do any polynomial. Okay, what is d over dx? Of x cubed minus 5x squared plus 2x minus 3. And what's nice is that there's a rule of derivatives that you're always allowed to break it up when you have pluses and minuses and constant multiples. Let's see if you can all do that derivative. And the idea is it's easy. You can put it in the chat box. Yeah, we start with the x cubed, and that's going to be 3x squared. And then we have a minus 5x squared, and that'll be minus 5 times 2 is 10x. And then we have the derivative of 2x, that's plus 2. And then we have the derivative of negative 3, and that's just 0, and I'm done. So polynomials are easy. Do y'all agree? Okay, I'll do another one. It's a little harder, but not that hard. Let's find the derivative of x squared minus 1 over x. Any idea how to do that?
Just split it up into x squared minus 1 times 1 over x.
You could do that, and that will work, but let me give you, but you can't do those individually like that. You can't just take the derivative of x squared minus 1, derivative of 1 over x, and multiply. That doesn't work. Does that make sense? But you could do a rule of algebra. What's the rule of algebra when there's a subtraction in the numerator, but there's no subtraction in the denominator or addition? Do you know the rule of algebra?
Can you possibly cancel?
You can split them. So we can write this as d over dx of x squared over x minus 1 over x. Okay, that's an algebra rule. Doesn't mean you remember it, but that was something you learned in algebra. Now, what's x squared over x? It's not called the quotient rule, by the way. We're gonna have a quotient rule right after the test, the second half of 3.3. Yeah, x squared over x is just x. And then 1 over x is x to the negative 1. And now we could use the power rule. That's just gonna be 1. And then we're gonna have a minus a negative 1 or plus x to the negative 2. And I'm done. Any questions on that example? Let me do one more before I talk about the test. That is, let's suppose that we want to find we have an x to the n, and we want the nth derivative of x to the n. So when you have parentheses with an n, that means the derivative. So we're going to take n derivatives. How do we do that? Any thoughts? So it's like the 5th derivative of x to the 5. It's going to be, but let's do it one step at a time. Let's do it. It is going to be a factorial, but let's take a look. You take the first derivative first. Okay, that's going to be n times x to the n minus 1 nth derivative, n minus 1 derivative. Now take the next derivative, and that's going to be n times n minus 1 times x to the n minus 2. And I guess that n minus 1 should be in parentheses, sorry. And that'll be the n minus second derivative. And if we keep going, the next time you're going to be multiplying by n minus 2, and then n minus 3, and then n minus 4. You can go all the way down until you have to the first power, and then it's times 1. So that is going to be equal to n times n minus 1 times n minus 2. I think I need to go new line. Dot, 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 which is equal to n factorial. Any questions at all on the nth derivative of x to the n being n factorial? So the third derivative of x cubed is 3 factorial, or 6. Okay, numbers get big, by the way. 10th derivative of x to the 10th is 10 factorial, and that's really big. I can't do that one in my head. Any questions on these examples? Okay, I want to spend the next 10 minutes talking about the test. Okay, so you have a test, and the exam is on Friday. So let me write this down. So it's this Friday, and it starts at 8:30 a.m. and ends at 10, I can't remember if it was 10:10 or 10:15. 10:10 or 10:15. I think it's 10:15 actually. a.m. Okay, so that's very important. Okay, it's gonna open up for you, and that's when you have to take it. If you have a special accommodations, you've let me know ahead of time, then take a look when it starts. And if you want to know, you can always email me if you can't figure it out. But start and end might be different depending if you have some accommodation. But if you don't, for most of you, it's just going to be 8:30 to 10:15, and that's it. It is Factorio. So that means that you're going to be needing a webcam. You'll be doing it at the computer, and I'm sorry you got to type it because it's at the computer. And computers don't do writing well. So you want to type it, and practice, practice, practice is the most important thing. Okay, just to note, here's question 1. All right? And I'm not giving you much help, by the way, showing you question 1. So question 1, write your name below if you agree to not communicate with any adult and not use any other devices or materials for this exam that have not already been expressly allowed by your instructor. Okay, and my definition of adult, by the way, is post-pubescent. So pretty much, and if they're over 12 years old, they're an adult. So if you have a teenager as a child, teenagers should be able to handle themselves. They could wait a couple hours. If you have a 2-year-old, that's different, and you need to help your 2-year-old, then I understand that. And if the video shows you helping your 2-year-old go to the potty, then that's what you have to do. But if you have a 15-year-old, tell your 15-year-old to wait. They can handle it. Sound fair? They're going to yell at you, but that's 15-year-olds anyway. Okay, so that's just a note. You can't communicate with any adult, and you can't use your smartphone. You can't use a calculator. Basically, you're at the computer. Okay, you can have a piece of paper You can have a piece of paper. And so you're not supposed to need a bathroom break, which means you should be using the bathroom ahead of time. Go to the bathroom at 8:20. Got it? And that should be enough. Okay, so go to the bathroom at 8:20 and you should be all right. Okay, so that's just a note. That's question 1. Okay, I need to stop share so I can get to the last question. Well, actually, I could have done it without. Just a minute. Question 10 is the only question in this whole class, only time in the whole class you get extra credit. It's an extra credit question. Okay, I had to make it worth something or the Canvas couldn't handle it. So I made it worth officially 0.01 points. I guess you could lose that, which is nothing, but you can get points. Okay, write down one thing your instructor can do to improve the calculus class, and write down one positive thing your instructor has done that has helped you in this class. If you write something, I'm going to give you full credit. Okay, but I don't decide what that credit is for everyone in the class until it happens. The only reason why you wouldn't get more than 0.01 points if you wrote stuff is if you have 100%. And then if you complain having 100%, you got a problem. Okay, so that's just a note, is that do this one. It's easy, quick, and you should get it. Then there are questions 2 through 9. Those are the ones I'm not showing you. They look like the quizzes. Okay, I mean, I'm not saying word for word, this is the quiz, but they got the same feel as the quizzes. Got it? I have a question for you. Do you tend to run out of time or do you have extra time in the quizzes? I don't have the ability to know. All I get to see is what happened in the quiz. Okay, if you run out of time, what I'm probably going to do is I'm probably going to shorten the test. I'm hearing a lot of run out of times. I don't want to kill you with time. So it's really hard. I've never taught this class in this environment before. And I hope I will never do that again, because I hope we have a cure for this stupid virus. I think you all agree too, but I can't do anything about it. And this is why I'm guessing. I don't know how much time it takes.
I have a question.
So it may not be 10 questions. I may get rid of some questions because I can't make it too long. Yeah, question?
Yeah, Mr. Green, I have a question. I forgot who brought it up earlier. I find myself finishing my scratch work in time, but then I'm having trouble typing everything in there. Would you accept like a picture of all the scratch work and send it to you?
The problem is the picture is done by smartphone. So I won't know if you see. I can't tell if you use your smartphone for other things. Does that make sense? And there are apps out there where you take a picture of a problem and it does it for you. Do you all know about that? That's why I can't let you do that. That app takes 1 minute, not even a minute. It's like a 2-second app. Do you see the issue? I don't know what a DSLR is. I see some notes in the chat box. I don't know what DSLR means, actually. So try to practice typing. The problem with the digital camera that isn't a phone is not everyone has one. I don't have one. So I need to be equal to everyone, and I can't say, well, if you're rich enough to afford this, that, I can't do that, or if you have time to buy this. Okay, so you need to type it out. I know you don't like it, but it's what we have to do.
Mr. Green, I have a question.
Yeah.
It's also kind of a suggestion. I don't know if it's possible, but if there was no time limit on the test, you could still see what tests were submitted after 10:15, right? So that could be a way. Do you know what I'm trying to say?
Yeah, see, I can make the time longer, but I can only do that if we have a unanimous vote.
Saying if there's no time limit, it would still end at 10:15. Whatever is submitted after 10:15, you'd be able
No, with Proctorio, there has to be a time limit.
Okay, that's all I was wondering.
Yeah, that's a Proctorio thing. Proctorio has to have time limits. That's not me being mean. That's Proctorio enforces. I can make the time limit longer, but then I have to do that for everyone. And I know some of you might have class after this class and you can't do it or work or something. That's the only reason why I'm hesitant about doing that. So I think I'm going to have to make the test shorter. And you know, that's something I'll do today or tomorrow because I still have a couple days. I've written the test, I've written a full key, but I can actually make it shorter because that's why I wanted to ask you if you run out of time or not. And if you run out of time, I'll try to make it shorter. Okay, but you need to type, so practice. And you know what? It's called the real world. When you get a job, it's going to be at the computer. Just let you know that. That's how you do stuff nowadays for professional jobs. So sorry about that, but it's a good practice.
I
So
appreciate
practice.
your insight. Thank you.
What's that?
I just appreciate your insight. So thank you very much.
Yeah, but I will make it shorter. Okay, that's something I'll do. So by the way, if it's not 10 questions, don't be surprised. I'm going to decide which ones to get rid of. And there's also A, B's, and C's. I'll probably get rid of some parts that you can't see. Question 1 and 10 will stay because those are nothing. There's no math in them. Okay, so that's just a note. So the problems look most like the quizzes. So redo the quizzes. What I have done, except for today's quiz, because I have to do that later on today, is I have set it up so you can go back to the quiz and look at it. You can play around with it. You can't increase your grade because that's something I would have to do. And you can re-look at the quizzes. The exam is supposed to be only 10 questions. The number of questions are totally up to me on the exam, by the way. So what's supposed to, there's no word on supposed to. It's however many I feel like you can do in the amount of time given. Okay? And I don't want to be mean. If I don't give you enough questions, then if you miss one problem, it destroys your test. So it's like, it's a pro and con kind of thing. To make it just the right amount so so that you're not like super pressed for time, but make it enough so that if you miss something that you don't get killed. Does that make sense? Yeah, for scratch paper, just show it at the beginning, put it at your camera, and then put it back down. The test all about derivatives? No. Test has a lot of limits. So the test covers from day 1. And in fact, what I did is basically I gave you a problem for each section, 1 or 2 problems on each section. Here's a couple questions that I do have in there. There is a true, false, and explain question. You're not used to and explain, but you have to explain why it's true or why it's false. So that's real important. So it's not all about derivatives. It's all about limits, continuity, and derivatives. Does that make sense? Okay, so don't just think it's all about the section we just finished. It's all of the sections we've done. So you want to go back and redo all your quizzes. And a lot of the problems look very much like the quizzes. Okay? Like if you take a limit of something, it won't be exactly the same something that you're taking a limit of, but you're going to take a limit. You have to prove something with epsilon delta. You're going to have to find out whether something's continuous. You're going to have to use the definition of the derivative to find the derivative. So there shouldn't be any big surprises on this test. It's the things you've been doing. Does that make sense? Oh, I just realized we're over time, so I'm going to kill the recording. Hopefully this will work. So I'm going to stop the recording.